So in this video we're going to talk about the graph data structure and we're going to see how we can represent them. So as we know, graph is a non-linear data structure and it is used to represent relationship or connections between pair of objects. So a graph consists of vertices and edges. So this V stands for vertices and the E stands for edges. So these vertices are basically points in a graph. Like an example, we have 1, 2, 3 and 4. So we have 4 points in the graph. Now the edges are the link between those vertices. So like an example, we can have connection between 1 and 2, 2 and 3, 3 and 4, and also we can have connection between 1 and 3. So that means here 1, 2, 3 and 4, these are basically vertices and the connection between them are called the edges. So this is one example graph which consists of vertices and edges. Now we can have so many different types of graph. Like an example, first of all we have directed graph. That means here in this graph the edges will have some direction. Like an example, from the edge 1 to the edge 2 we have some direction. Secondly, we have undirected graph. So in this type of graph we do not have any direction. We can say that we have a connection between 1 and 2. Similarly, we have weighted graph. So in this type of graph the edges have some kind of cost or weightage. Now fourthly, we have unweighted graph. So in this type of graph all edges have equal value. So here this is one example of undirected graph because here we do not have any direction, and this is one unweighted graph because here the edges do not have any weight or cost. All the edges are considered equal. Now we have so many different uses of the graph. Like an example, the graphs are extensively used in the social networks. Secondly, the graphs are very important in case of the web page linking. So multiple web pages are linked together and they are based on the concept of this graph, and also used in case of routing and in case of scheduling, and very importantly it is used in case of computer networks. So the graphs can be represented two ways. First of all, we can use adjacency matrix, or secondly we can use adjacency list. So first of all, let's just talk about this adjacency matrix. So this is basically one matrix. It is one n by n matrix where this n is the number of vertices of the graph. So we basically create one n by n matrix and we fill that matrix either with 0 or 1. Now suppose this is one matrix M, which is n by n matrix. We have the M matrix, the position I and j will have the value 1 if there is edge between vertices I and j, else we're gonna fill that position with the value 0. So suppose we have this graph, vertices 1, vertices 2, 3 and 4, and we have edge between them. So we have edge between 1 and 2, 2 and 3, 3 and 4 and 1 and 3. Now we can represent this graph using this adjacency matrix because here we have 4 vertices. So this will be one 4 by 4 matrix. So we're gonna have 4 rows and 4 columns. Now according to this theory, if we have edge between the vertices I and j, then we're gonna fill that matrix with the value 1. So here you can see in our graph we do not have any self loop. That means from the vertices 1 to 1 or from the vertices 3 to 3 we do not have any self loop. That means the diagonally all the values will be 0. Now because we have connection between 1 to 2, that means here we're gonna have value 1, and also we have connection between 1 to 3, here also we're gonna have 1. Now we do not have any direct connection from 1 to 4, that means here we're gonna have 0. Similarly from 2 to 1, so from 2 to 1 we have connection, so here we're gonna have 1. From 2 to 3 we have connection. 2 to 4 we do not have any direct connection, so here we're gonna have 0. From 3 to 1 we have connection. 3 to 2 we have connection. 3 to 4 we have connection. Now from 4 to 1 we do not have any connection. 4 to 2 we do not have any direct connection. 4 to 3 we have one connection. So this is our adjacency matrix for this graph. So let's now talk about this adjacency list, how we can use that to represent this same graph. So in case of this adjacency list, we use linked list for each vertex. So because here we have 4 number of vertex, so that means we need total of 4 linked list. So we need linked list for each of the vertices. So from 1 we have direct connection to the vertex 2, and also we have direct connection to this vertex 3. Similarly from this vertex 2, here also we have to maintain one linked list. So from 2 we have direct connection to 1. So here we're gonna have 1 in the linked list, and then it has direct connection to 3. So here also we're gonna have the vertex 3. So from this vertex 3 we have connection to 1. So here we're gonna create one linked list containing the vertex 1, and also we have connection to 2. So we're gonna create this node with the vertex 2, and also we have connection to 4. So here we have to create the node 4. Now for the vertex 4, here we have direct connection to 3. So that means here we're gonna have the node 3. So you can see for each of these vertices we are maintaining one linked list. So in case of this adjacency matrix, we have the complexity of order of n square because we have this matrix of n by n size. So for this adjacency list, we're gonna have the complexity of order of n plus 2e. So here n is the number of vertices that we are using, and then here plus 2e, that means 2 edges. So because here we have the duplicate edges, for the vertex 1 we are showing the edge from 1 to 2, and also again we are showing that same edge in case of this vertex 2. So here we are showing the edge from 2 to 1. So because of this duplicacy, we have the complexity of n plus 2e. So we have two ways to represent the same graph. Now the efficiency of these two representation depends on whether the graph is dense or that is sparse. So suppose we have so many connections, in that case this adjacency matrix will be the best idea. Now in case the graph has less connection or the graph is sparsely connected, in that case this adjacency list will be a better idea. So hope you understand about the graph and the different ways to represent the same graph. See you in the next one. Take care.